Have you ever stopped to wonder if the laws of physics, the same ones that govern how a ball falls to the ground or how light travels through space, are really the same everywhere in the universe? Or are we just assuming that we have discovered in our tiny cosmic neighborhood a place to the vast unknowable stretches beyond? Let's explore a truly mind-bending idea. What if the laws of nature we rely on every day are just a local truth? What if, like a person living in a desert thinking the entire earth is dry, we have only seen a small part of the full picture? Imagine a man born and raised in the heart of the Sahara. He has never seen a river, a lake, or the sea. To him, the world is dry. Sand dunes stretches out for miles, and water is more precious than gold. Now imagine he is asked to describe the planet Earth. He might say with great confidence that water is rare everywhere. But we know better. We know that 71% of Earth's surface is covered with water. His perspective isn't wrong, it's just limited. Now replace the man with humanity. Replace the desert with our observable universe, a tiny portion of the whole cosmos. Replace water with physical laws. And now ask yourself, are we making the same mistake? We speak of the laws of physics as if they are eternal, carved in bedrock of reality. Newton's laws of motion, Einstein's theory of relativity, quantum mechanics. These aren't just theories, they are the foundation stones of the modern science. But here's the catch. Every experiment, every observation, every test of these laws has happened within a very small region of the universe. Most of them, in fact, have been confined to Earth, or at most our solar system. Imagine someone trying to understand the entire game of chess by watching just the first few moves. They might see only pawns moving and conclude that's all there is. That's where we are in cosmology, just watching the opening of a much bigger game. Let's pause and understand the scale we are talking about. The observable universe, the part we can see with our best telescopes, is about 93 billion light years across. That's already unimaginably huge. But it may be just a tiny patch in a much larger, possibly infinite cosmos. It's like trying to understand the layout of a giant forest while standing on a single hill and only seeing the nearby trees. You can make assumptions, but you can't be sure until you explore more. So when we say things like the speed of light is constant everywhere, or gravity behaves the same across the cosmos, we are really saying, as far as we can tell from our tiny hill in the forest, these things seems to be true. One of the strongest reasons we believe in uniformity across the universe is the cosmic microwave background, the faint afterglow of the Big Bang. This light has traveled for billions of years and seems to suggest that the early universe has a kind of smoothness and constancy. But even that constancy has tiny fluctuations, tiny temperature differences, which we now believe seeded the formation of galaxies and stars. Could those differences hint at larger variation in physical laws? Let's stretch the imagination. What if there are regions of space where the speed of light is different, or where gravity is repulsive, not attractive, or where the fundamental particles, electrons, quarks don't exist at all, replaced by entirely different building blocks? It sounds like science fiction, but leading theories in physics like string theory, quantum gravity, and multiverse hypothesis all suggest that this is not only possible but even likely. In string theory, for example, different vibration modes of fundamental strings could lead to completely different physical realities. And in multiverse models, each universe could have its own set of physical laws, like different rule sets in different computer games. Think of our universe as a game of Monopoly. The rules are fixed. You collect $200 when you pass go, and you go to jail under certain conditions, and so on. But imagine another board game, say chess. The pieces, the board, the objectives, everything is different. What if the universe is like that? What if our universe is one of the game board with one set of laws, and there are countless other boards out with completely different rules? Even things we call constants, like the speed of light, the gravitational constant, or Planck's constant, might not be so constant after all. These are researchers who spent decades looking for tiny variations in these numbers across space or time. Some have claimed to see small hints, but nothing conclusive. Still, the possibility remains that these constants are more likely environmental settings than universal truths. Maybe the universe isn't tuned for us, maybe we are tuned for the universe. That is, life only evolves in regions of the universe where the physical laws are just right, where stars can form, where chemistry works, where stable atoms exist. So maybe there are infinite regions with different laws, but we live in this one because it's the only one we could survive. That's the anthropic principle. And while it doesn't answer the question, it reframes how we ask it. This brings us to the most exciting and humbling question. Can we ever really know if the laws of physics are the same everywhere? Right now, our tools are limited. We can observe galaxies billions of light years away, but we can't visit them. We can measure cosmic radiation, but we can't run experiments in a black hole. Yet science has a habit of pushing boundaries. Maybe one day we will develop techniques to probe these mysteries more deeply. Until then, we must live with the uncertainty. You might ask, why does this matter after all? Whether or not gravity works the same in a galaxy 10 billion light years away doesn't change your day-to-day life. But it matters because it reshapes how we understand our place in the universe. It teaches us humility, that our knowledge, however vast it may seem, is still limited. It encourages curiosity, pushing us to deeper questions, and it invites wonder, the kind that has always driven human discovery. So next time you hear someone say the laws of physics are universal, remember the man in the desert. His view wasn't wrong, just small. And maybe, just maybe, we are standing in the vast cosmic desert, unaware of the oceans of possibility just beyond our sight. Thank you for exploring this idea with me. Keep questioning, keep wondering, and never stop reaching for the stars. Thank you. One of the strongest